Now we are starting with the chapter alternating current. Okay. Alternating current is what? It is a type of current in which, see, read from here. An alternating current is that current whose magnitude changes continuously. What does it mean? Magnitude means if I am taking the magnitude on y-axis, okay, and the values which are written on the y-axis are changing continuously. See, at these pointers, they are different, right? With time, like as soon as the time will be proceeding forward, like it's 1 second, 2 second, 3 second and so on, gradually when it is increasing, the magnitude will also be changing. For an example, at 1 second the magnitude is somewhere here, at 2 second the magnitude is somewhere here, kind of thing. Okay, so that type of current is called as alternating current. Now when a coil is rotated in a magnetic field, then an alternating EMF is induced. We already understood in the previous chapter, that is electromagnetic induction, about what is EMF and how it is getting induced. So when a coil will be rotated, for an example, I am putting the coil here and I am rotating that clockwise or anti-clockwise, okay, any position, then what will be happening? It will be changing the flux which is linked with that coil. Flux means the number of lines which is linked with the coil, and due to that the EMF will be induced. So we have the formula of the induced EMF, that is the original value of E naught multiplied by sin omega t. Now we have the value of the current, that is I. We know by the formula Ohm's law that V is equal to IR, and in this chapter we used to refer V with the word EMF, which is equal to IR. So I value can be calculated by EMF R is equal to I. Okay. So EMF value we already wrote here as the function of sine. Like I am saying that if this is the graph of alternating current which is varying continuously with time, then according to that we have the function which is written for the EMF of the new value, that is E naught multiplied by the sine function of the particular graph. So I'll be substituting the value of E, which is the final E, in terms of the original E naught, that is E naught sin omega t divided by R. So now I got that I will be remaining as it is. E naught by R will be I naught, because R will not be impacting anything. It's just the value that we will be able to calculate for I naught. So we got the value I is equal to I naught into sin omega t. So we have the punctuations for the following terms or the notations, that is I is equal to instantaneous current, not induced current. Okay. I naught is equal to the peak or the maximum value of the alternating current, which can also be referred as the current amplitude. Write down this formula. Now we have the word amplitude. What is this amplitude called as? Okay, before proceeding further, just make sure one thing. This I naught is peak or the maximum value. Peak or the maximum value. I'm repeating it again. Okay. So what is the different definition of amplitude now? So the maximum value which is attained by an alternating current in either direction. In either direction means if the alternating current is proceeding in the upward direction or it is proceeding in the downward direction, then this maximum value which is being obtained, this value is called as maximum value, peak value, or the amplitude of the given function. Okay. Now this is also referred to as the peak value or I naught that we was talking about here in this formula. Okay. So next thing that we should know about is the time period word. Okay. So the time taken by the alternating current to complete one cycle of its variations is called time period. We already had the formula that frequency is equal to 2 pi f is equal to omega. Frequency can also be written as omega by 2 pi. Now we know that frequency is the reciprocal of the time period. So 1 by t is equal to omega by 2 pi. Now we can just reverse the values. So we are getting that t is equal to 2 pi by omega. So we got the formula here. Okay. Write down this formula. Now we have the word frequency that I just now made you understood, that the number of cycles completed per second by an alternating current is called frequency, which is depicted or notated by small f word, which is equal to 1 by time period, and we know that it will be omega by 2 pi now. So by multiplying this term on the left hand side upwards, we are getting the original formula, that is 2 pi f is equal to omega. Clear? We have a very good note that alternating current supplied to our houses is 50 hertz of frequency. We should know about this. We are understanding physics, so we should know that the alternating current which is reaching our houses is 50 hertz of frequency. It's universal. Now this is an important proof that used to be asked in exams, that you have to prove mathematically that the average value of alternating current over one complete cycle is 0. So we already understood the formula that I is equal to I naught sin omega t. Write down. Now we know current is equal to charge by time. So we can write the charge value as I multiplied by the time, which is equal to Q. So if I am taking the small type of charge which is flowing, dq, then it will be I into dt. If the charge will be smaller, then time period will also be smaller. That's why we are writing this. So we wrote it here that also dq is equal to I dt, and in place of I am substituting the formula from this part, that is I naught sin omega t, and dt will be as it is. Okay. Now the total charge, if I have to calculate, see, mark my words, I am saying the word total charge. Total means integration on both the sides. So the total charge will be, we are integrating this, and I told you a trick that you can just remember in your mind, but do not mention that in your notebook, that this integration sign can be deducted by this derivative form. So we are getting the whole q. That will be equal to the integration on the right hand side also. So integration from the initial value of time period 0 to a complete time period t, that will be I naught sin omega t dt. Now I naught is a constant value, so we can take it outside of the integration. And now we know that integration of sin theta is always minus cos theta, right? So if I am considering this as theta, so sin omega t integration will be minus cos omega t, and by the chain rule of integration, whatever will be along with the variable will come in the denominator. So we are writing as a whole minus cos omega t over omega, and integrated with the definite integrals value 0 to capital T. Now this I naught is written outside, right? Now omega also I can take it outside. So omega can also be written as 2 pi by t. So I wrote it. Okay. Any doubts? I said omega can be taken outside, and I know the formula of omega or time period, that is 2 pi by omega. So omega can be written as 2 pi by t. So omega was in the denominator, so 2 pi as it is, and t will be going in the numerator. Okay. Now minus cos omega t will remain as it is. We have to put the values, first of all t and then 0. So let's start substituting now. So I naught into capital T by 2 pi. So minus cos omega value I can write 2 pi by t multiplied by small t value with the first integral, that is capital T. Then minus will become plus, because in between minus sign used to get inhibited. So 0 when I will be putting here, so 0 multiplied by omega will become as a whole 0. So it cos 0. Okay. Now I naught t by 2 pi I am writing as it is, and I am getting the formula from here that minus cos 2 pi. 2 pi is always minus 1. Cos 0 is 1. So it will be getting deducted and getting 0. So 0 multiplied by anything will be giving us the answer 0. So from here I got that the average value of the current which was written with q by t is always 0. Okay. Now you can note down this derivation by pausing the video. Now, why ordinary moving coil galvanometer cannot be used to measure alternating current? This is a very theory portion, that ordinary moving coil galvanometer is based on magnetic effects of current, which in turn depends upon the direction of current. This we already understood in the previous chapter. So when it is depending upon the direction of the current, so if current will be in the clockwise direction, then AC will be in a different manner. If it is in the anti-clockwise direction, it will be in a different manner. So that's why it cannot be used to measure alternating current. Now during one half of the cycle of the AC, its pointer moves in one direction, and during the negative half or the next half cycle, it will be moving in opposite direction. Now we are taking that the average value of the alternating current over a complete cycle is 0. right? Now average value means half of the way it's going upwards, half of the way it's going downwards. So average is the whole sum of this portion will be 0. Understood? So even if we measure an alternating current of low frequency even, then also the pointer will be appearing to be stationary at the 0 position due to the persistence of the human eye vision, because we can't see the microscopic things. So we can measure alternating current by using a hot wire ammeter, which is based on the heating effect of current, and this effect is independent of the direction of current. So that's why now we are going ahead with the formula that when average value is not a considerable option to measure the value of the current, then we are going at a value that we will be understanding now, RMS current, that is root mean square current. Okay. Now to understand what is root mean square, it's easy to go from back to forward. First of all, whatever values will be given to you, just square those. For an example, I'm taking 1, 2, 3 values. Okay. First of all, you have to square, means 1 square plus 2 square plus 3 square. Then you have to take mean. Mean means average, means number of observations sum divided by total number of observations. So divided by 3. Okay. Now root. This is the value of RMS if you have to do numericals. Now let's calculate what is mean or the average value of the alternating current. So it is that value of direct current. Mark my words, it is that value of direct current which sends the same charge in a circuit in the same time as it is sent by the alternating current. A good thing, right? So we have a relation which is relating to average value and the peak value. Average value is written with I average. Peak value is written with I naught. Okay. Now we had this relation which is I is equal to I naught sin omega t. We also know that dq can be written as I dt from the previous derivation. Now we can again substitute this value here with multiplied by dt. In order to calculate the whole charge, we have to integrate. Now the difference is because we are calculating the peak value, and peak will be reaching only in a half cycle, right? Only a half cycle will be required. So we are taking the time period from not 0 to t. We are taking from 0 to t by 2. Only half version. Okay. Now let's go ahead. So we are putting the limits here 0 to t by 2. Earlier case we substituted the value from 0 to t. Mark my words. Okay. Now 0 to t by 2 and doing the same thing just like we did earlier. So we are again integrating the value of sine, that is minus cos omega t by omega. We are again putting the value of omega outside and putting that 2 pi by t. Inside also I am putting 2 pi by t. Now substituting the limits, that is t by 2 first of all. So we are getting cancelled by this thing, but now getting here cos 90, that is minus 1. Cos 0 is again minus 1, right?
Cos 180.
Yes, sorry, cos 180 is minus 1, cos 0 is also minus 1. Okay. So now we are getting that this minus and the minus taken from here will be getting cancelled, and we are getting the answer t I naught by pi. So we are getting the formula t I naught by pi. Now to calculate the average value of the alternating current over the first half cycle, we will be doing q by t. T will be now t by 2. So we are getting the formula 2q by t and putting the value of q here as whatever we derived from the first part, that is I naught into capital T by pi. We will be deducting capital T and getting the formula 2 I naught by pi, which is we have to learn both the ways, either this way also the formula wise and the numerical wise, that is 0.637 I naught. How we calculated this? 2 divided by pi value. Then we can just learn it directly. Okay. In the similar manner, we have the value for E average, that is 2 E naught by pi is equal to 0.637 into E naught. Okay. This is the value of the average. Okay. Now we are going ahead with the calculation of the RMS. So in that case, we are taking that it is defined as that value of DC which produces the same heating effect in the given resistor as is produced by the given alternating current for the same time period. Now its relation for the effective and the peak value of AC first of all. Okay. So this we will be doing in the next lecture because it's again a derivation. and then we'll go ahead with the numericals. Thank you.